Now we talk about the conversion of numbers from one system to the other. First, we talk about the conversion from binary to decimal. Let's see, for example, we have these numbers 1, 1, 0, 1. Now, if and when we have this number, right, we can actually, of course, convert it from this to decimal. And to be able to do that, we put it inside these special cells. It's a horizontal cell. So all of these numbers sit side by side to each other, and we need to know that they are base 2 numbers, and we need to convert it to decimal. Right? Now, once you put them into these horizontal cells, you start putting the number from 0 on the rightmost, right? So you remember that the smallest number will be on the rightmost, and then this is bigger than that, this is bigger than that. It's because of the positioning. The more towards the left it goes, the higher the value for the position, right? So this is 0, this is 1, this is 2, 1, this is 2, and this is 3, right? Now, we can just convert it to decimal. How? First we take the leftmost one, 1 times 2 to the power of 3, or 2 cubed. Right? Put it in a bracket so you know that you've done it. Then you just strike it off like that. Plus 1 times 2 to the power of 2, or 2 squared. Again, we put it in a bracket, and then we cancel it off. Right? Next is 0 times 2 to the power of 1. Right? Again, we cancel it off. Right? And the last one would be 1 times 2 to the power of 0, 2 to the power of 0, and we strike it off. Now, next is you getting the numbers one by one. 2 to the power of 3, or 2 cubed, is 8. Right? Plus 2 squared is 4, plus 2 times 0 is 0, plus 2, rather this is 1, 2 to the power of 0 is 1, plus times 1 is 1, right? And we get 13 base 10. Easy enough, right? So even if it's a complicated number, it can be like a totally complicated number like this. For example, a long number is not really complicated, it's just a long number, right? So you just put them into cells one by one. Put them into cells, all of these horizontal cells, right? And then you just write from the rightmost, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, right? And then you just do it one by one, break it down one by one. Once you break this, for example, 1 times 2 to the power of 8, then you just strike it through, put in bracket, plus 1 times 2 to the power of 7, right? You strike it through, and then you do it one by one until you're done with the number you're looking for in binary or in decimal format, right? Right. Yeah. Okay, next is the conversion of a decimal number to binary, right? For example, I'll just give you this number, 78 base 10. You want to convert to binary. So how do we do that? Similarly, we take the number 78 and we put it into cells, right? Just one cell, of course, right? But this is like it will be like downgraded from base 10 up until it goes to base 2, something along those lines, right? So it's a special cell where all the numbers will be divided by 2, right? And again, it's a special cell that only accepts round numbers, meaning it does not accept 1.1105, for example. It does not accept these things. No! It only accepts round numbers. So because of that, if and when we see an odd number, you'll see the consequences. Wow, are you nervous? Okay, so if it's 78, it's fine, right? 78 divided by 2 would be 38. Okay, 38, 38, 35, 6, 7, 8. Oh, sorry, it's 39 actually. 18 or 16, yeah. 39, I made a mistake there, right? So if it's 78, it's fine, meaning we don't take anything out, we just take 0 out. But if it's 39, now this is an odd number. And if and when it is an odd number, you divide it by 2, you know that it will be 19.5. And we don't want the 0.5. So the only way we can solve this is by taking 1 out from 39. You take 1 out, it becomes 38. 38 divided by 2, you get 19. Oh, another one of these numbers, another one of these odd numbers. So you take 1 out again, it becomes 18. Divide by 2, you get a 9. Right? Again, you take 1 out. Divide by 2, you get a 4. Right? 8 divided by 2 is a 4. So 4 is a round number. Sorry, it's an even number. It's a round number and an even number. So you don't take anything out, you just take 0 out. Right? And divide by 2, it becomes 2. Everything is divided by 2, you see. Right? And once you have 2, again, you take 0 out. And then 2 divided by 2, you know that you get a 1. And no matter what you do here, you won't get anything smaller than this. Right? This is the last one. So once you get a 1, stop immediately. Don't do this. Some people, for whatever reason, they add another 1, meaning 0 and then 1 at the bottom. I wonder why they do that. Please don't do anything else. Once you get the 1, stop immediately and take the number from the bottom to the top, and you get 78 base 10 is equal to 1001110. Right? 1001110. Right? So we talked earlier about bits and bytes, where bit is a binary digit. It's either a 1 or a 0. Right? Bit, binary digit, get it? It's like some kind of a pseudonym kind of thing. Like canary digit is cat. Not really. But anyway, bit, or rather a byte, is 8 bits. We talked about this earlier, like a dozen is 12. Right? So a byte is 8 bits, and this is commonly used for transfer rate. Transfer of data. For example, your modem might be 100 megabits per second. Right? So for transfer rate, we use bits, which is denoted by a small cap b. Right? Whereas byte, which is 8 bits, is commonly used for storage. For example, your hard disk can be 500 gigabyte, and here we use the all cap or capital B. Right? So it's different. Right? Now, of course, once we know this, we also need to know these things, you see. You notice as well about these things. Giga and mega, and every now and then you see kilo and whatnot. So this is just a simpler way of representing things. It's like, for example, instead of saying 1,000 grams, you can just say 1 kilogram, right? So it's a matter of simplifying things. Instead of saying 1 million, some very geeky fella might say 1 mega, which is 1 million, right? So kilo, mega, giga, what are these things? Have a look at these. It's called denominator. I'm not sure. Right? So kilo, mega, and giga. What do these mean? Now, if say you go to the market and say you want 1 kilogram of fish, that means basically 1,000. Right? So this is in our numerical system. In the decimal system, the human system, 1 kilo is 1,000. But computers are pretty weird. It's because they want to stick with the simplicity kind of thing. And if say they want to come up with 1,000 like this, it will be a combination of numbers like this. For example, 1, 1, 1. Let's see. I need to refer to my notes for that. Right? 5 ones followed by 0, 1, 0, 0. Right? So this is equal to 1,000 base 10. And that is not easy to do for the computer. Remember simplicity. I don't want to represent kilo like this. It's so hard for me to do, the computer says. So instead of doing this, the computer sticks with this. The kilo for the computer, and I'll write that using a blue marker, kilo for the computer is actually 2 to the power of 10, meaning it's 1 followed by 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? And when you do it like this, right, you end up with the number 1024. Right? So 1 kilo for the computer is 1024. 1 kilo for us is 1,000. Why is 1 kilo for the computer not 1,000? Because the computer does not want to do this. They said, no, I'm protesting, I'm picketing, I'm lobbying against this. I want simplicity, so I want this, says the computer. Right? And so we follow through with this similar concept when we have mega, right, which is technically 1 million. The computer says no, mega is not really 1 followed by 6 zeros. Base 10, right? Mega for the computer is actually equal to 2 to the power of 20, or rather 1 followed by 20 zeros. That is for the computer, right? So this is the human system, this is the computer system, right? And so giga goes like that as well. For the computer system, giga is actually equal to 2 to the power of 30. Right? To know how much that is, you can calculate or refer to your slides. Okay. But anyway, this just means that if you go to the market and say 1 kilogram of fish, and the computer goes to the market and say 1 kilogram of fish, the computer will get 24 grams more. That is unfair advantage.